It's all about being rational. Or at least that's what we tell our students, to always rationalize the denominators in their fractions. But how would you rationalize the denominator in this fraction? 1 over the cube root of 2. We cannot just multiply the top and bottom by the radical in the bottom because, well, that's just not going to work like it does for square roots, as you can see. We will still get the cube root of 4 remaining in the denominator, which is not a rational number. No, what we actually have to do is we have to multiply the top and bottom in this fraction by the cube root of 4, or the cube root of 2 squared in other words, because then that will make 3 copies of 2 inside the radical, which will then neatly cancel out with the cube root. So as a general principle, if you have to rationalize a fraction that has a single nth root in the denominator, then you have to multiply the top and bottom of the fraction by a particular radical that completes the nth power, so to speak, so that afterward you would have a perfect nth power inside the radical, where n, of course, is the index of your root. So if you have a square root, then n equals 2, and if you have a cube root, then n equals 3. So overall, this fraction will simplify to the cube root of 4 all over 2. But how would we rationalize the denominator in this fraction? 1 over the cube root of 2 minus 1. So now we cannot just multiply the top and bottom by the cube root of 4 like we did in our previous example. That will not work. I'll leave that for y'all to check. No, what we actually have to do is we have to invoke the difference of cubes formula, which you might recall looks like this. A cubed minus b cubed is equal to the quantity of a minus b times the quantity of a squared plus ab plus b squared. And what we're going to do is we're going to let a equal to the cube root of 2 and b equal to 1. And that will then imply that the quadratic term is the cube root of 4 plus the cube root of 2 plus 1. And it's that quadratic term that we actually need to multiply the top and bottom of our fraction by to rationalize its denominator. So doing so, we would get the numerator to be, well, the cube root of 4 plus the cube root of 2 plus 1. And if you notice, the bottom now can be multiplied out using the difference of cubes pattern. That's kind of the whole point of this trick. So doing so, we would just get the cube root of 2 cubed minus 1 cubed, which would just simplify to 1. So overall, this fraction rationalizes to be the cube root of 4 plus the cube root of 2 plus 1. Pretty neat, right? In any case, I'll let y'all think about how we would rationalize fractions that contain radicals of other indexes. It will proceed in a similar fashion to what we did here. All right, with that, I hope you're doing well. Make sure to hit that follow button for more math content. And as always, I'll catch y'all in the next one. Take care.